All right. Let's have. Actually, let's open this thing up in IntelliJ and see if it actually works. So if you're going to use IntelliJ, one of the things that it's very useful to do is to get this JetBrains toolbox, because here's the thing about IntelliJ, right? If you're using IntelliJ to develop Dotty, you kind of want to use the latest IntelliJ nightly build, because it's still sort of a moving target, because the language hasn't been released yet. So, but you probably want to run a regular IntelliJ alongside that, maybe, because the latest nightly build might not necessarily be stable. So that's why this thing is really good. What you could do is you could tell it easily, okay, I want to run this version, and oh, by the way, I have this other version right here that I can run anyway. So by the way, you can install IntelliJ if you're using WSL, right? You can install IntelliJ you can install JetBrains Toolbox into WSL. This is actually, again, this is running out of WSL. So anyhow, so I can launch it, and this thing launches for me. And in fact, I have this thing. I have this thing right here. Normally, to import it, what you have to do is you have to do new... Oh, wait, sorry, not new project. You have to click on open. In fact, let's see. Let's remove it. Let's see if we could recreate that project. Let's see if we could recreate that project. Let's wipe out the idea directory. Okay. And let's see. And then you do open. And then you point to that directory. And it will open it up. There are a couple of things that you need to know. Let's see. Here it is trying to sync with SBT, which it has. And then here are my projects. Here's the... Oh, wait, no. Hold on. Where are my sources? One of the things that you need to do with this thing to get it to work is that you need to make sure that... let's look at it here for a second. You need to make sure that here in SBT, in settings, you have, let's see, use for project reload and builds. And that'll tell it to use SBT to actually build the project. So let's do that, and let's reload. Let's see, what's it complaining about? Oh, I actually added a clause here, which is incorrect, so let's get rid of that. And this should stop being read in a second. And so now over here, it's initializing the project. This takes a minute. Also, IntelliJ might run out of memory in this case. You'll have to give it more. Let's see. Importing Instantiating compiler. At some point, it's going to do some indexing. There we go. Now, the other thing is, also at some point, it asked me, let's see, it asked me what version of Scala to use. And that's coming from, let's see, right here. At some point, it asked me what version of Scala I should use, and popped up with this menu right here, but you actually don't need to have a Scala built on your path, so that menu is irrelevant. Basically, it'll ask you for a Scala SDK if it hasn't imported the project correctly. Like, you would see a sidebar, or excuse me, like a little bar up here saying cannot find Scala SDK. It means the project isn't actually imported correctly. But anyway, here we are. So we can actually write in this, right? It recognizes inline. It recognizes some of these things. You know, you have autocomplete. If you do a dot, it will at some point tell you what's in here. So it gives you method autocomplete, like better method autocomplete than VS. As you can see, my machine is a bit of a jet engine now, so it's somewhat of a memory hog. Oh wait, no, hold on 1 second. It's still instantiating the compiler. Yeah. Okay. So the other thing to keep in mind is that there are things that, in general, I haven't really figured out exactly what they are, but there are things that will make IntelliJ turn into a jet engine that are kind of hard to understand. Like, for example, if you have lots of objects in the same file, so if you declare an object and then use it, like declare this quoted object and then use it throughout this file, or this query object and then use it throughout the file, IntelliJ can, you know, go off like a jet engine, literally. So stuff like that. I don't know exactly what all those instances are. I don't know exactly what they are, but in some situations it happens. So the point is that sometimes you sort of have to play around. So let's see. Let's move this thing out. Query. And again, just keep in mind you are using a pre-beta version. This is literally the latest nightly branch, so stability is not necessarily guaranteed. Okay. Let's see, let's move this out. Quota. Alright, see, it was smart enough to import io.getquill.ast when I moved this file here, so IntelliJ is a slightly nicer experience. Let's see. Ooh, in this case, .ast, but we need to, because there's a query object in .ast, this thing is like, oh, query io.getquill.ast.query does not take type parameters, and there's the declaration of io.getquill.ast.query. So we have to make sure that .query is not imported from here. And so we can just change the name. We can say query goes to a query, which is the AST version of the query. And so now it's happier with this. I don't know if you saw down here it said instantiating compiler again. But anyway, let's see if we can use this thing to write the Unlifter implementation. So here's what else did we have in here? Object, right? There's the parser. There's the lifter. We can move some of this stuff out. Lifter. Oh yes, well, moving out the lifter again is a little difficult because then we have to do the same thing as we did for the unlifter. Remember that for the unlifter, what we did was, where's the unlifter? We called it the Unlifter Engine, and ooh, well, it's resolving the reference. Undo Scala class. What? Cancel? Cannot. So this is annoying. You try and control click on something, and it says cannot perform the operation, too complex, sorry. And that's kind of annoying. It does that frequently. So I don't know why, but it's just weird. Or when you want to click on something, like you want to click on something and have it go there, and it just doesn't do it. But you can do, like, I'm pressing F1 for quick documentation, and that'll give you some information on what you're looking at. But anyway, if you want, so here's something important to note. So one of the ways, well, this particular way that we've used to propagate this quoted context here inside of the Unlifter engine is that we propagated it through the constructor here. Now, one of the other assumptions that I've made is that the way that we have the quoted context inside of this quote implementation is that this is sort of implemented as a method that exists inside of the object. In the actual code base, this is done a little differently. The way that I have it there, so for example, lift macro. The way that I have it there is that I define this inline, and then the actual implementation I define in a separate object in the apply method. So this is actually .apply. And this allows me to define the implementation in, like, this object that's sort of abstracted away. And it's sort of a nice pattern that I like to use. So, for example, let's say that I would have something like this quote impl. Instead of doing quote impl, I would have something like object quotation. And then inside of quotation, I would then have a method that would have this exact type signature. And so, like that. And then what I would do is I would call apply, like that. And then once I have that, then basically I can copy the entire implementation that I've got here. And then let's include the lifter, la 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 la, and all of this stuff here, right? Like all of that is this one big method here. So then we can just take all of that giant stuff and move it over into here. Then, once this is moved over into here, what we can actually do is we can take this thing and we can move it out to a different file. So, this is going to be quotation, apply, and then let's create a new object called quotation. And so now, let's take this out. And IntelliJ will nicely tell you, right, where that top quote is. And, and it'll even tell me what imports I need to make. So that's nice. Except that it doesn't actually do that 100% correctly. As you can see, I've got ident, and I've got a couple of other things here that, and I need to do seal. A couple of other things here that aren't exactly right. So it's definitely not a perfect system. Let's see, AST property entity string operator ident. So it has to be ident. And let's see what else. And now, since I've refactored this, I also need unseal. But that's fine, because I've already written unseal. And I have a pattern for how to import unseal. Which means that I can just reuse that. Where do I have unseal? Unseal util. Let's bring in unseal util. And now I've got that. And that works. And there's just some other minor detail. No implicit of quote context. Unseal util has to actually be declared inside of the apply method because it needs a quote. Wait, no, hold on. Unseal util is already here. Unseal util is already here, so all of this should be fine. No, the only other thing. Why is this not fine? Where is unseal util? Unseal util is here. And so I think the imports are bad. I think the problem is that the imports are bad. Let's change the imports to be the same imports as the file it's coming in from. And so hopefully now the imports will be more correct. Let's go dot. And the Unlifter Engine. Where's the Unlifter Engine defined? So the Unlifter Engine is defined in here. We also need to take that out. Let's see. New Unlifter Engine. So now we've got that there. Again, let's just change the imports to be exactly what we have in the other file. Okay. And what else? What else? Unseal util. Not found unseal util. Oh, wait. Did I forget? No. Packages there. Quotation. Packages there. Packages there for that. Packages there for that. Unseal util. Where's the unseal util? Oh, the unseal util is also inside of this big DSL object that was here. So now we have to make a new file for that as well. There's our unseal util. Okay. Well, there's our unseal util. Good. So now we've brought a bunch of other things into some separate files. And now we've got quotation in here. We've got a parser in here. We've got our lifter in here. So this is the pattern that I use fairly frequently. Lifter. Inline def unlift. Inline def unlift. Unlift we're gonna apply. Okay, there we go. So there's my unlifter to apply. I do have 1 second. I do have an unlift method as well. And there it is. Where's my... There's the Unlifter Engine. 1 second. Where's the DSL again? Query, run, and unquote. Excuse me. There's my unquote. So, all right. Let's compile this and let's see if it works. You can actually do build, rebuild project, and again, that's the point of enabling the compile with SBT. You typically want SBT to be doing your compile as opposed to IntelliJ because, well, IntelliJ gets it wrong sometimes. Okay, well, of course, now unseal util is no longer in DSL. And unseal is no longer in here because we put it somewhere else. Wait, no, hold on, no. Unseal. See, because this was importing from the wrong place, it then complained and said, oh, we can't find it because this import that contains this thing here, right, this thing here comes from this import here. Because inside of this thing here, right, this thing is defined. So obviously, if you don't import that correctly, it won't be able to find it. Does that make sense?
Yeah.
Okay. Let's try build, rebuild project. Again. Okay, good. Okay, now, in the next part of this, let me show you the Unlifter Engine. The challenge that we had with this thing before was that if I didn't have this unlift library here, things kind of went to hell. And I am uncertain as to, well, I think I know as to why, but I'm not 100% certain. So basically, and this is one of these things, again, sometimes it's just trial and error. And so I started putting this in here. So let's see. We have an entity unlifter, right? That's how we did it here. And what we need to do is we're looking for a similar kind of thing with say identities. By the way, this is apply unlift. See, I tried to look up apply unlift, and then it gave, it blew up and gave me this error. We have no idea what you're talking about. So again, IntelliJ is not perfect. I don't think it could probably, let's see, could it rename this? Introduce variable, extract, no, we can't rename this thing. It wouldn't be able to do that. It should, but it can't. So again, not fully featured. Anyway, I'm actually curious. What happens if we rename this? Do we rename this? Ooh, let's see. Did that compile? Well, that's nice. At least you can rename top-level objects. Actually, that'll be quite useful because in the real code base, I've got some big packages that I need to rename. So, also, obviously in IntelliJ, the Git integration is nicer. So let's see, Git, rollback, 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 rollback. Okay. Build, rebuild project. So let's go back here, I guess, and the goal was we were in our Unlifter engine. The goal was, ooh, can we see project structure? Oh, cancel. Is it Command P? View. Parameter info, navigate. Where was my project structure? Control Alt P? Where are my keyboard shortcuts? Keyboard. Project. File structure. What's my, oh, no, it's Control P. Oh. Okay, I guess I'll also add Alt P. Because coming from Mac, everything is with Command key. Anyway, there. Okay, we have file structure. That's already more than VS Code has. That's nice. Anyway, so let's try to write some clauses. Actually, you know what I want to do first? I want to show you, now since I've actually taken the time to update this thing to the latest version of Dotty, Before it was 0.22. If you remember now, this is 0.27. So Scala 3 is almost out, by the way. If you look at if you look here, well, Dotty becomes Scala 3, but that's not what we're interested in. Have a look at this, right? The latest actual Dotty version is 3.0.0 M1. Now, the version before this, right, this is not out yet. The version before this is 0.27.0. So it's getting there. So this is basically the latest release candidate. So that's what we're on right here. And the reason why we're not on the latest nightly build with this is because we need to use this utility, or in a project, we will need to use this utility called Scala test to run our tests. Anyway, so let's see. Let's see what. So Scala 3, one of the big things it does is it gets rid of implicits. It gets rid of implicits, and it has two mechanisms that are being used to replace implicits, right? So for implicits, you have implicit definitions or values, right? This is an implicit def. It could technically be an implicit val. It can't be an implicit def if there's like a key in here, because then you have to define it in there. But it's not in this case, so it can be an implicit val, or it could be converted to an implicit val. But then it's like arbitrary. Like, what, okay, is it an implicit def? Is it an implicit val? And this is an implicit class, and you pass an implicit object to an implicit class, right? It's kind of arbitrary. Implicit is sort of an overloaded term in Scala 2. In Scala 3, implicits are replaced with two other mechanisms. They're replaced with extension methods, and they're replaced with something called givens. So let me demonstrate how an extension method works. So for example, let's see. Object main parts array string. So the way that extensions work, for example, is, let's say that I want to do something like val Joe equals to Joe, right? So I have a string. And what I want to do is I want to do something like, say, someone. Someone dot is Joe, right? Well, the way that you do that in normal Scala is you do something like implicit class, let's say string extensions, and str string, right? And then you do something like def is Joe Boolean, and you do equals str equal to Joe, right? Now, or dot to lowercase, la la la, right? However, whatever business logic, quote unquote, you want to put into it, right? That's how you do this in Scala 2. Now, oh, and by the way, if you want to have this implicit class use some other implicit, right? You do something like, let's say you want to have, let's say you want to have Joe be a string, or let's say, gosh, I don't know. Let's say that an integer can also be a Joe, right? So then let's say we define a trait Joe, right? And then on a Joe, you can call def is Joe, which is a Boolean. And then we can define something like def implicit def string Joe. And a string Joe is going to be a excuse me, no, sorry, this needs to take a type T. And 1 second, actually. Sorry, I'm confusing myself here for a second. Right, sorry, my bad. Let's say is Joe is going to take some kind of T. Some kind of parameter. That's the way the abstraction goes. Right, and then you can have a string Joe, which is going to be a Joe of string. Which is going to return Joe of string, new Joe string. Then def is Joe, T string, and then you do something like T dot equal to T dot to lowercase equal to Joe, and then what, let's say something like this would rely on would be a, let's say, implicit string Joe, which would be a Joe of string, and this would be string Joe dot is Joe of our implicit thingy. And of course, when you want to extend that to other things, like let's say we have an int Joe, there's going to be an int here, and an int here, and an int here, and you can't do two lowercase. Let's say an int Joe is 3, or some nonsense like that, right? So then what you can do is you can then start parameterizing, and you would actually say, no, this is not a string, this is something, and this is something here, and then you can use this implicit thingy that we summoned here, and then what we have is we have this some.
I'll be right back.
Something. Sorry. Sure. Some Joe of something, and then we call is Joe on something. Now this is sort of the pattern behind doing stuff like this. Now let's delete all of that for a second. And let's just pretend that this is just that. So instead of implicit classes, and let's take that out for a second. Let's take the simpler case. Let's take the simpler case. We don't have a dependency in this situation. We just say there we go. So how does this work in Scala 3? Well, the way that it works in Scala 3 is like this. We have something called a extension.
Sorry about that.
You didn't miss much. Extension str S extension. What just happened here? Extension st. Wow. And this is the problem with using a super beta version of this thing. It kind of fails randomly on you and does weird crap. Let's see. Let's close this stuff and open it back. Extension. Oh my god. Extension. str string. Come on. So this is defined as an extension on string. Holy crap, this is really bad. Really, really bad. 1 second. What's going on here? Follow her. Blah, 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 blah. Failing for reasons that I don't entirely understand. Weird. Let's try without this thing. No, still bad. Extension on string. Define is Joe, which is Boolean of type Boolean, str equal to Joe. So this is the way that you do something like this in Scala 3. So this is like, this kind of makes more sense, right? We're defining an extension method on a string, and then we can call that extension method. Let's see if we can actually run this thing from IntelliJ. Now let's actually print line. Is it Joe or not? Okay, so you can actually run it from IntelliJ. And again, oh wait, can we actually control click on this thing? It may or may not work. So you can define extension methods. Now, extension methods, now how do you actually like define something like this, which is a type class? How do you actually define a type class? So the way that you define a type class is a little bit different. It's called a given. So the way that givens work in general is that you have something like, let's say we want to define a string Joe or something like that. So we would say something like given string Joe as Joe of string. And then we define is Joe. Oh, well, it'll actually give it to us. And then we have the same by name notation. And then same thing, give an int Joe as Joe of int. Same thing, def is Joe. It nicely tells us t equal to. So this is kind of nice, right? We don't, it's like, okay, given one of these, you can do that with it. Instead of, you know, all of this weird stuff with implicit definitions and implicit classes, it's like, okay, we have this thing, and this thing is of a particular type, and we just define it. We don't have to worry about whether it's an implicit def or an implicit val. It's kind of obvious that way. So, and by the way, what's kind of cool is that you don't even need to give them a name. You can just do that, right? There exists a Joe of string. There exists a Joe of int. We don't need to give them a name. They technically don't need to have names. Now, how do we use these things, right? Because before we plugged it in to our class, right? We actually used it. So the way that you use these things is, instead of, again, overusing implicit, it's using. So in this case, it would be using Joe of string. So it's using, let's call it string Joe. And then you would just do string Joe dot Joe of str. And it did not give me a complete for that, unfortunately. So this is how extension methods are used using sort of new way of doing things. So I'll let you see these two things side by side. Let's call it the new way, object the old way. This is the old way of doing it. And right, let's take this out. And let's put another main here. And something of t. Required string. Oh, right, we're not using the string Joe, we're using a sum Joe. There we go. So this is the new and old way of doing these things. Oh, and one other thing. What's the difference? There's something I haven't done yet. Look at what this is capable of doing, and look at what this is capable of doing. What is this capable of doing that this is not?
Assuming an object other than a string?
Yep. Right? See, if you don't have a t, you can technically do something like that. Right? We can define one for that. Right? We can do that. Right? But that's kind of ugly. We need to define one for every single kind of object. Well, you could do the same thing for this. Right? You could do int, and you could do int. Right? You can do that. But again, the stuff like that is ugly. So that's why we want to be able to define these things generically over a type t. Type t. Now, in here, you can also define a type t. You just put t before that. And then you change that to t, and you change that to t, and it works. So that's how you do it in the new way. And again, an extension can have a name, but it does not need to have a name, because you don't necessarily need to give it a name, because you're just using it. You don't care what its name is. Now, FYI, we've got this new way of doing it, and we've got this old way of doing it. Something that is sort of something which is interesting to understand is that, so let me show you. Let's say that we have this, and then instead of using this, the new way, let's call it XYZ for a second. And let's replace the givens with implicits. And this still works. So the way that this is actually implemented internally is like this. And the way that these guys are internally implemented is like this. So givens and using is internally implemented using implicits, which is why, oh, we're using them, oh, these are actually implicits. So, basically, it's the same mechanisms that ties them. So it's not like you have to use one mechanism or another. They're built to integrate together with one another, because it's really the same thing. And you can do the opposite, for example. You can have something like, instead of right here, what we did is these two instances we used together with this. You can go the other way. You can go with let's say we wanted to use the implicit class. Let's say we wanted to use the implicit class together with these two functions. Or excuse me, the opposite. We wanted to use the implicit class together with these two givens. It's trying to import Joe from up here because we've redefined Joe each time. So when we bring those over, it's like, oh, you're using this Joe. We just copied and pasted from here, and then it's like, are you using this Joe? Why don't we import it, right? Did you guys see this, right? We're taking this thing, we take this thing and we copy it here. Do you want to import the new way.joe? So do you want to import in this thing this guy? No, we don't. We defined our own Joe here, but IntelliJ doesn't know that. It does its best to figure it out, but it's not always right. Anyway, so does that make sense, by the way?
Yeah, it does.
Okay. So yeah, also you can use this implicit class together with these givens, because again, implicits and givens are actually the same thing. So they are mixable and matchable. Practically speaking, if you're going to do one style, I suggest you stick with that style as opposed to mixing them, but they're supposed to be completely interoperable. So anyhow, which way do you guys like more? Do you guys like it more the new way or the old way?
I kind of like the new way because it's a little less verbose. But I'd have to use it.
Sort of the philosophy was that the new way sort of, it expresses your intention. You know, I intend to create given instances of things, as opposed to the old way, which is like a mechanism. I'm defining implicits that plug into other implicits that's supposed to do things, as opposed to, I want a given this of this. So I think the new way is better. I think they put a lot of thought into it and they figured it out. Anyway, so here in the Unlifter, back to where we were, right? What we can do, if we so desire, instead of implicit, right, we could do implicit class, we could do extension. We could do extension has let's see, extension oops. Extension has Unlifter T. Extend. Oh, why is this not finding it? Implicit. Let's see. We do that. Let's see, extension key. That's fine. No, that's not fine. Extensions should be able to have names. I guess they can't have names. Interesting. I thought they could have names, but they can't. Okay. So anyhow, extension, and then this is an unlifter. Oh, and by the way, if it tells you extension, it'll tell you using. Okay, we're doing a using. And by the way, if we want this entity unlifter here, right, we can also change it. But let's go with the old style for now, since that's what we started.
I think I'm gonna crash for a sec.
Okay. So anyhow, we were what were we doing here? We were looking at how to do this unlifter here. And let's see, we have this entity here, which we're trying to figure out. We have this entity here, which we're trying to figure out. So, okay, let's see, IDAS. So what we need to do for this, is just like we did in our lifter. Let's have a look at what we did in our lifter again. We moved everything out to quotation, which is now where all of this stuff is. So let's have a look at IntelliJ. Ugly indentation job. Let's look at our AST lifter. We have ident, we have entity, we have filter. So this is all kind of similar, except for that what we want to be able to do is, for example, we want to be able to write a identity lifter. Well, here's our clause for an identity lifter. Let's write our identity unlifter, and this case, we have to write it inside of here. Let's move this. Let's move this up here for a minute. So we want to write a unlifter for identity. Now let's see. Will IntelliJ tell us what this is? Well, that's kind of ironic. Right, IntelliJ actually won't tell us the type of this thing. See, if we're in here, let's reload this whole thing. If we're in here, where's our Unlifter Engine? Here we go. If we're in here, IntelliJ will tell us what this is. This is a ident. And it'll tell us that this is an expression of an ident. Well, IntelliJ won't. It won't tell us what these things are, and I don't know if it even knows. So IntelliJ is unfortunately not the solution to all issues. But anyway, we know that this thing here is an AST of ident. So let's write a unlifter implicit def ident unlifter, which is an unlifter ident, new unlifter of ident. Okay, right, and let's define unlift. Element, right, again, it is going to be an expression of ident. And it goes from expression of ident to entity. And then element, match, right, and then at this point, we're just abstracting out what we saw in here. Or, excuse me, what we saw right here. Right, we create our identity object. Let's see, unlift, ident of name. Oh, right, has to return ident. Right, so mirror image. We go from expression of ident to ident. In the lifter, we go from ident to expression of ident. In the unlifter, we go from expression of ident back to ident. Mirror image. Okay? So now we have this has unlifter here. Okay. And so at this point, right, we don't call this apply anymore because this is apply and there's no clause in this apply for parsing the ident anymore because we just moved it out into there. So dot apply unlift, which is this function here. And we can actually just change that to unlift. I think we can. Can we do that? I think that's okay. Let's try compiling. clean compile. Oh, something blew up. What blew up? Let's try it again, compile. One of the things that's useful to do is if you have one error and it's stuck in a giant compiler log, comment that out and recompile all the other parts. But anyway, let's see. Ooh, cannot unlift the tree. Ah, what have we here? We cannot unlift an ident. Why can we not unlift an ident? What did we do wrong? Implicit def ident unlifter, unlifter of ident, expression of ident turns into an ident, and we unlift it. Oh, that's right. Okay, it works from here because we call .unlift, but what happens if an ident comes into this apply function directly, right? What if it's a case ID of ident? What happens if it's that? Right? What happens if it's just that? Well, we didn't cover that case, so we have to. There we go. And now it works. Right, so then we'll go on to do other things. Okay, apply query AST. Ah, now hold on, let's see. We have property, we have binary operation. Oh yes, let's change this thing, right? Let's change this thing and use this sort of pattern. Right, we will have a binary operation unlifter. We will have a binary operation unlifter. What happens if we, sorry, just for my own entertainment, extensions, give it a name, using unlifter extension t.elem. Extension on t.elem using unlifter. Oh, it's good. All these lines are bad, but it's good. This is actually, unfortunately, the case for again, for VS Code, it will tell you things are wrong when they aren't actually wrong. And by the way, one of the simplest ways to get rid of this problem is that if you close it and reopen it. And so now it's not complaining. Given doesn't need a name. Given doesn't need a name. Doesn't need a name. That. Let's see if we could write in this style. Given unlifter of binary operator. What does it need? It needs a unlift method. Def unlift lm expression of binary operator. Goes to a binary operator. lm match. And now this whole gigantic thing here. Oh, whoops, we have to import a bunch of stuff first. Okay. We have a bunch of imports. And then we define our lifter. I'm not LM, but and there we go. Voila. And so now we don't need this anymore. That's pretty nice. That's pretty nice. Again, if we want to go back to the old ugly way, implicit def op unlifter la equals to new, one of these, and same darn thing. Implicit def entity unlifter is an unlifter of entity equals to new, blah 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 blah. Implicit def ident unlifter. Lifter of ident equals to new, blah blah blah. Implicit class has unlifter. And we have come full circle. Let's see. Oh, yes, and now binary op. We just do unlift. Okay. Now, what's the only thing that truly remains? The only thing that truly remains is that we haven't abstracted this out. Remember how in here, now that's over there. Remember how in here we abstracted out the unlifter for the base AST. Right? We use the same pattern. Okay, let's use the same pattern. Implicit def AST unlifter. By the way, this does not have to be at the end. It can be here. The order does not matter. Unlifter of AST. New unlifter of AST. Def unlift of AST equals to def unlift, which is going to be an expression, let's call it expr AST, becomes an AST, equals to all of this wonderful stuff in here. Minus the apply method. That obviously does not go there. So all of this wonderful stuff here that we have just copied and pasted. Okay. Okay. Well, there we are. We have our AST unlifter. And of course, what that means is we no longer have this apply thing here. It's all just going to be unlift. Property AST unlift. inside AST, unlift, a expression, unlift, the expression, unlift, and of course this will be expression dot unlift. And voila, we have hereby refactored our unlifter to also use this pattern. All right. Now, let's actually commit this before we move forward. Now, I actually want to check out one thing.
Before we continue, can we see the new implicits again?
Oh, sure. You want me to do this for the new implicits one more time?
I just want to know like which ones are which. Like implicit def goes to what, implicit class is what.
Okay. So the way to think about it is you think about it in terms of what it is. The idea is this, right? The way that type classes work. The way that type classes work. It's actually one second. Okay. You know what? I'm not going to do that. The way that type classes work is like this, right? This is an entity unlifter, for example. And we've defined this unlifter and this entity unlifter. And we've defined this thing here. And then we have this. This has unlifter thingy that tags on a method, and finally we have something like val e entity. Let's say expr, and then let's say that's an expression of entity equals to val ent. It's going to be an entity. Is going to be expr dot unlift. What does this, using, we could say implicit, what does this mean? What does it mean? The problem is that there's a lot of mechanism in here. Like this is actually that, right? But this kind of hides behind the scenes. So we kind of think about these mechanisms. But what does it mean? What do these things represent in reality, right? So when we think about polymorphism, we think about, let's say that this was written in traditional polymorphism. We would have something like this, only we wouldn't have a T. We would have some kind of unlift. It might take something, it might take some kind of expression, Something like that. Maybe it does take a t, doesn't matter. At the end of the day, it has some expression, and it returns some, let's say some r, some result, or something like that. So let's say this takes some r. In fact, we could even put an r there if we wanted. Now, let's say we wanted to define class entity unlifter, right? That would extend unlifter of entity, right? And then the unlift method, would have an element, and this would be an expression of, right, just fill in the r. And that would be entity, right? And this would be a subclass of the unlifter. And then, finally, at some point, we would have some kind of expression that would come from somewhere. And then, so this is where sort of the tricky part comes, right? We would have something like entity unlifter, right? And then we would do something like that, right? And then we would have dot unlift on the expression. Something like that. But the thing is that we have to do this sort of flaming hoop jump here. And we're like, okay, we have to declare this thing on here. And we have to declare it and use it. But how do we actually tie one of these things to an instance of that? Right? We've defined a class to have this functionality on this guy here. Of course, the alternative is where you have something like class expression. Right? So let's say we've defined a class expression. And then let's say we want to define an unlift on it. Okay. Expression can be of t. Well, how do we define every single possible kind of unlift on it? So we can start going through these things, and we can start saying, okay, let's do class unliftable expression. Unliftable expression, let's say, extends expression of t. An unliftable expression, let's say this thing doesn't exist here. Let's just say expression is some expression that's floating in the air, and unlift has a t on it. So for example, class unliftable entity expression would extend expression of entity. Or in fact, it would extend unliftable expression of entity. And it would define an unlift that would return an entity. And then we would continue on and on and on, right? And we would have oops. There we go. Let's say we would have an unliftable ident expression, right? And then we would go on and on and on to define all of these things. So what's the link? What's the missing link? This is functionality. An unlifter is a verb. It's a verb. We have these verbs. Unlift this. A verb can be made into a noun, right? An unlift can become an unlifter. An execute can become an executor. A do can become a doer. A download can become a downloader. So we have these verbs that we've made into nouns. And it's this verb called unlift that we just want to tie to this expression. And so we want to be able to say, given that there is something that lets us unlift this thing, do it, right? This is actually like gross, right? This is gross. This leads to things like the Hadoop API, where you literally have to define yet another one of these for every single damn thing in your hierarchy. Unliftable property expression, blah, 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 blah. You have to define every one of these for every single one. But what is this? What is this? What is this, an unliftable expression? What does an unliftable expression mean? It means a frickin' expression that we can unlift. So the real meaning of this stupid thing here is the following, is that we just want to say exists somewhere, or basically exists an unlift of T. Given that there exists an unlift of T, given that there exists an unlift of T, then hack A, or sorry, not unlift of T, unlift of the expression of T. Given that you can unlift the expression of T, right, because that's what we're trying to do, we're calling it an unliftable expression. So given that you can unlift it, there is some function out there that can unlift it. Something in the world that can do that. Tack a dot unlift method onto an instance of expression T, right? Where an instance would be like inst of expert, right? So here's the logic. Given that there exists something out there that can do this, then allow us to call inst.unlift. That's the point, is that we want the flexibility to declare something like that. Otherwise, right, we have to do gross things like this. So, okay, what does it mean there exists an unlift function somewhere out there? Right, what does it mean? So, we can define there exists a unlifter. Okay, that's worse, but that's still not so bad. Given that there's some unlifter out there that has the ability to unlift this thing, and then let's say given exists an unlifter that can .unlift expert T. Okay, given that there exists an unlifter that can unlift this guy, star, 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 then tack an unlift method onto the instance. Right? This is what it means. So, let's go back to has unlifter. Right? Has unlifter, or given a unlifter. Right? That's what has unlifter means. Right? Or has unlifter actually is the second part. Right? Given that there exists a unlifter, at some point actually in Scala this was even given here. They changed that, but I think that was the best way to declare it. But given that there exists a unlifter on some t, on some expression of t, given that there exists an unlifter on it, then tack on the second part, right? Tack on a unlift method onto an instance of the expression. So one more time, let's actually translate, right? Given there exists a unlifter of t, that, by the way, has this unlift method, okay? Given that there exists this unlifter of t for some expression of t, tack on this method. Does that make sense?
Yeah, this makes a lot of sense, actually.
Okay, cool. So what does it mean? What does it mean there exists a unlifter? Well, here we've defined him. This is our unlifter, right? This is like define an unlifter of entity called entity unlifter. Blah, 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 more ceremony. It happens to be that we need to define him as a class instance of this trait, blah, 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 blah. Whatever. Define a unlifter. Declare, even better, declare there exists a unlifter of entity called entity unlifter, which, by the way, we don't even care what it's called because we don't actually use. We only care what something is called if we use its name as a variable. We don't even care what this thing is called. Right? Because we implicitly say given that it exists. Okay, but whatever. We have to give him a name. Let's give him a name. Oh, here he is. We've defined him. Okay? And this thing here is saying, this is like our tacker. This is our method tacker. Right? So that's what these things mean. So let's copy this and let's just go back to where it was before. So here's a slightly more elucidated version of what this stuff means. So again, given there exists an unlifter for this expression of t, tack on this method onto an instance of expression of t. And in this case, we're just saying declare an unlifter of entity and give it this particular name. And here's going to be its internal implementation, right? So what the Scala 3 people said is the following. They said, okay, guys. So first of all, we actually don't care about most of this. Why is it an implicit class? That's just arbitrary. This simply means that we are tacking on an unlift onto some expertise given there's an unlifter for it. Why on earth do we need to call it an implicit class? Oh, we need to call it an implicit class because really what we're saying is we're saying this. Instead of saying this, really we're saying this. We don't care. This is a mechanism. This is a mechanism. We don't care what the actual mechanism behind the scenes for it is. We want intent. We intend to say, tack on an unlift to an instance of expression of t, the sky, if there exists a unlifter for it in the environment. So we don't need to have all this ceremony. We could say extension. Or extensions, yeah. Extension, define an extension or some extension for an expression of t given that we have this guy, given that we have an unlifter for it. And originally it was given, now it's using. Fine. Close enough. Right? So given that we have this guy, define an extension for it like that. Okay. Okay. Now, how do we define this guy? Again, implicit def, who cares whether it's an implicit def or an implicit val or whatever? All that we care about is we are saying, given that we are providing a given, a instance of this. And we don't care about its name because we don't even use it. We're just saying, there is given in the environment. We are giving it to you. Here is your unlifter of entity. Here it is. Take it. Use it. So that's what these things mean. And yes, there we go. So now you can compare and contrast, right? This thing, let's put them all together. We can put them all together in one place. This thing used to be this, and this thing used to be this. This is intention. Provide. Actually, a better thing than given would be provide. They argued about what the words for this should be for like forever. So this is, we establish that there exists an unlifter of entity. This is intent. This is mechanism. Means the same, ultimately means the same thing. Same thing here. We're declaring that there exists an unlift method on every instance of this thing, given that you have an unlifter for it. So here, this is the new way and the old way in a nutshell. Does this make sense?
Yeah, perfect.
Okay, cool. All right. So I guess I'll leave it the old way. You know, you guys, if you so desire, convert it to the new way and just check that it works. Oh, and this is not using. Like using is almost a replacement for an implicit. Like any parameter, which is an implicit parameter, coming in, you can change it to using. Right? You can't change this, that won't work. But if it's an implicit parameter, you can, if it's like a parameter that's being passed in, so to speak, you can change it from implicit to using. Anyway, so here's the unlifter. The truth is that actually there's this is the way that it is right now, but we're going to change it a little bit because in Scala they've actually I didn't know that they would be making this change, but they've actually defined their own library for unliftable. In fact, you can see it here. Let's see. Can we see it here? No, we can't see it here. They've defined, Scala internally has defined a system of unliftables. So instead of defining our own, we're going to be using theirs. And I'm going to change this to resemble how to use theirs. It is going to be simpler. But anyway, but that's, I'll tell you about that, but first I want to actually work through it myself and make sure that all that works. So, you guys wanted to talk about goals. Yes, no?
Oh, yes.
So, okay. So, the long-term goal is completely unambiguous. The long-term goal is the successful release of Dotty, or of Quill for Dotty, or for Scala 3.
Interesting.
The successful implementation of Quill for Scala 3. That's going to combine a bunch of pieces. The piece that I envision you guys doing is the parser. So,
okay.
The goal is to implement the full Quill parser in Scala 3. So here's the full Quill parser. Let's fire that. So the full Quill parser parses what is it? About 20 different constructs, or what is it? 30 different constructs. How many are we here? This is actually roughly, this is a fairly decent outline of the parser. This isn't exactly, certain things are going to change, but this is roughly it. This is 20 constructs approximately. Now, 5 or 6 of them I already have implemented. So, for example, right, this is the parser that parses queries. So we have all sorts of parsing that's done for queries. This is a .filter. This is a .map. .withFilter. .withFilter is similar to filter. What you can notice is that all of these are basically the same thing, except for that this part of them is different. They're all quite similar. Which means that, not every single one. There are some that are different. But there is definitely a lot of repetition. Which is why I think this goal is very, very, very doable. So, here's what this involves. What this involves is this. Taking every single kind of construct that exists in all of these clauses, looking at how it's parsed, looking at what this thing is intended to parse. So this, for example, is intended to parse a query. And then implementing that in here. here is the real code base for Dotty Quill. Implementing that in here. So here is the new quotation parser. Or let's look at the query parser, actually. So here's the new query parser. So this is the new query, these are the new query clauses. So this is .map. So this over here is this over here. So the point is to move, for example, for the query parser, to move every single one of these clauses, this one, and 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 the full, all of these clauses here, into this query parser here. Now, again, it's not exactly the same. One of the issues is that there is some duplication because in the old one you only needed to do things like map once, so you need to do .map once. And here you need to do it for this guy and for this guy, so there's going to be some amount of duplication. So they're going to be a little bit different. But the point is still, it's pretty darn similar. Basically, move these clauses, and the entire set of functionality that this thing does into here. And that's the query parser. Similarly are all the other parsers. So for example, let's say the function parser, right? Take this function parser, figure out what it does, and I will assist with all of this. This is actually what the function parser does. It parses an invocation of a function. So here is the equivalent function parser here. What this thing does is it parses a generic function. Now again, it has to be a little different because there is no way to use this, this sort of typed API that we have up here, or excuse me, down here, right? There is no way to use this kind of highly typed API to do something very loosey-goosey like this, right? What does this mean? We have some function that has some parameters and has some body. Well, you can't do that with Scala 3. It demands much more typing. So it has to be done differently, and that's the challenge. So the function parser in this case has to be done by parsing the raw tree. But again, most of the functions that you'll need to use this, or at least a lot of them, I've already written. So this is raw lambda n. In other words, when I call it raw, it means, all that raw means is that it's returning terms as opposed to expressions. This and this have the same functionality. So for example, parser. So for example, here's the function parser. Oh, and this is the part that needs to be implemented. This is the part that's remaining. What is this part? This part basically says that if you have some kind of anonymous function that somebody has written, so right, this, like, you'll recognize this apply thing. So this is like a typical Java pattern where, in order to implement a function, right? How did you implement functions in pre-Java 6. How do you implement lambdas in pre-Java 6? Right? You would do something like new lambda, and then you would have def apply. And inside of that def apply, you would have a generic parameter, and you would have some other, like A, B, C, and you could have like A, B, C, A is A, B is B, C is C, and this would return some type R. And this basically here is saying, guys, if you see one of these things happening in your code, right, because then someone would actually use it, and they would say something like, query person dot filter, and then inside, instead of saying p2p dot name equal to Joe, they would say something like new lambda, or something like that, or just new generic function, def apply, and then let's say p person equals to p dot name equal to Joe. If you see some garbage that looks like this, which is what this thing here is saying, right? If you see some garbage that looks like that, throw this particular error. Right? Well, you will not be able to do this. You will not be able to do this using this super typed kind of functionality that we have here. You just won't be able to do it. So what you'll have to do is you'll have to create an expression that looks like this, and you'll have to figure out how to parse it. Well, that's actually not that hard, right? What you'll have to do is you'll just plug it in. You plug it into your printing macro, right? You'll see what the tree looks like. It'll actually even give you the extractors. Then you'll write a little example parsing macro like this and play around with stuff until you can get something to match it, at which point you're done, right? So then that's how you'll implement. That's how you'll implement this clause right here. That's how you'll implement this clause right here. Right? It's just going to be writing a custom object with an unapply function. That's what a lot of this stuff is. And then, as reference, just look at, again, raw lambda n, for example, right? This is a function with an unapply. So, in this case, for some construct like this, you're just going to have to write some kind of unapply function that matches whatever tree results in this that you'll have to investigate. So the goal...
sorry, Alex.
Huh?
But I should go too.
Oh, all right.
I should go too to do some work.
Oh, sure. We're almost done.
Yeah, before.
So the goal is...
Oh, okay.
So
do you have an estimate?
Here's the thing. What I want by November, and this is like something that you guys can show, is a basic parser for most of these constructs. I've actually gone through them. They should be up here. But here they are.
Okay, I see. Yeah, I read this.
Basic implementation for these parsers. Most of them, they're actually implemented in one form or another. The other important ones is this one and this one. And potentially some others. A basic, like, form of them, a skeleton of them, that can then take other things. That can then be extended.
Okay.
Ultimately, the point is to implement all of these parsers, all of these clauses, and to implement the full parser with the full functionality. As
This is good because we can use this in our goal with our professor.
Yeah.
In the meantime,
should we start assigning these to start looking at them?
Well, I actually had a question for Picard. Could you help schedule a meeting with everyone that we can go on our own to try and get this started together and assign tasks and figure out what what work we want to do individually and together as well?
Yeah, sounds good.
Yes. Yeah, I should schedule a meeting like this week.
Yeah, let's do it. Let's say Thursday because I have midterms tomorrow and Wednesday.
Yeah, wait, also, wait, what about the email that we're supposed to send tonight, is it?
Yeah, I don't know, what is that email about? We're supposed to send... Yeah, so can Ricard, can you compile that email with, you can simply repeat what Alex just said, by November we're going to have a working,
No, not about that. I think he wants information about this particular week, that what we'll be doing this week.
So then just simply tell him that we're going to be meeting together on Thursday after our midterms to collaborate properly on starting this parser.
Okay, sounds good.
And then we'll also investigate the other components and other parsers and try and delegate.
All right, sounds good.
So yeah.
All right, so I'll be.
No, go ahead. Go ahead.
I'll be watching this VOD later.
So the way that
I'll be watching the rest of this later. So I'm gonna leave.
The way that this is gonna work.
Good luck in midterms.
Sure. The way that this is gonna work, roughly speaking, is that again, for every single one of these constructs, you'll have to look at the trees that you need to parse. Now, I actually indicated sort of sealed or unsealed for each one of these, sort of to the best of my knowledge. Sealed means you'll be able to use the actual, sealed typed API like that. And so whenever I say sealed parsing, it should actually be fairly simple. Like you can use this syntax here and directly port it from this syntax here. So for example, the ordering parser. Let's have a look at the ordering parser. Here's the ordering parser. Okay. Well, there are just a bunch of orderings that you can do. This is you can do an order by in Quill. So this parses the ordering. Well, this is actually typed, fully typed. There's no ambiguity about what any of the types are. So what you should be able to do with these things is that you should be able to just translate this syntax into this syntax here, and you should be able to do it just by properly specifying the full io.getQuill package, and maybe you might need to specify a type or something like that. Or for this thing, right, the .ilems, what you'll need to do is you'll need to use this generic sequence. And so instead of the .ilems, you'll use this. The rest of them, right, this is a fairly simple port, right? Same thing with the join call parser, right? So if you look at here, the where do I have the join call parser? Actually, the join call parser is probably should be up here. Where's the join call parser? Lift parser, val parser, conflict parser. I should add the join call parser here, actually. Let me add that here. Right, the join call parser, again, everything in here is basically fully typed. What that means is that you will just be able to take the syntax, move it to the syntax, and it should just work. So, generally speaking, the things that can be moved directly are fairly simple. The things that need to be done with an unsealed parsing and that need to be done directly on the tree like we have here, those are more complicated. So that's the criteria that I've used to categorize all of the different kinds of parsers that need to happen. Does that make sense?
Yeah.
Okay. And the other thing is that I think that, either for our next session, or the session after that, basically, I will take one of these and show you guys how to move it across. And at least get you started for that particular parser. And then we'll go parser by parser, and we'll get that started. And so, we'll take the next amount of weeks that we have, and we'll just go through them. Does that make sense?
Yeah, I think that's good. I think that's yeah.
Okay.
Wait, Alex, about the release, the cut you were talking about, the Quill for Dotty, that cut. When do you expect to release that?
That's dependent on several other things. I expect that to be released sometime from mid to end of next year. There are probably going to be a couple of release candidates before that. There are other things that need to happen. So, of course, Scala 3 needs to come out. That's like a big dependency. The other thing that needs to happen is I need to do a bunch of stuff on my side. So, for example, there are things like inserts, right? So right now, Dotty Quill allows inserts. It allows selects. It does not have the functionality for inserts and updates yet. It has a basic framework for that. In fact, I'll say more than that. It supports things that are more complicated than those, but it doesn't support those yet. So and again, depending on how fast we finish this parser, and I think that once we get started with this, we will churn through it actually fairly quickly once we start going through it. If you guys have some time, then maybe you can help me with that as well, implementing some of those other macro things. But that's a downstream kind of thing. The other thing
Alex, do you expect any of those cut candidates? I guess before March. Oh, sorry, not March. I guess. What was the date that Salvage gave us? Was it April 10?
I have no idea.
Yeah, I guess we'll just take March.
So if you want to do like a mini release, or if you want to do like a prototype or an alpha release, that's totally doable. Totally doable.
Yeah, because I think that would look good. I think that would look good on paper. I think that would look far better on paper.
Okay.
Than just Parser.
So by March or April, what we could do is we could do an alpha release of. We should aim for an alpha release that includes hitting every single one of these constructs, or the vast majority of them. And then writing them and testing them. Every single one of them, again, in a basic way. I don't expect to have every single variation for things like, say, binary operations, or things like, let's say, the pattern matching parser, or any of these really complicated things. I don't expect to have every single variation. I expect to have one or two, and those can be iterated on. But yeah, that it's doable to have a small stub for all of these, and maybe decent, like, fully fledged implementations for half of them or a third of them, and even that would definitely warrant like a prototype release, just so that the Scala community can see that it's out there and start playing with it.
That sounds fantastic.
Yeah. The other thing that I haven't mentioned is that right now this is on Quill 3.5.2. The major change in Quill after 3.5.2 is the introduction of quats. Or, the SQL types. And I need to write a quat parser for the types. And that's also on me. That's the other sort of major dependency. Whether that will be done by March, I do not know. It depends on how similar or how different the type representation of Dotty is to Scala 2. If they're similar, if they behave in similar ways, then some of that at least will be done. If they're quite different, it won't. So again, it depends on a few things.
Yeah, sounds good.
All right. Well, I'll let you guys go then. Have a good evening.
Cool.
Thank you, Alex.
Thanks, Alex.
Have a good
All
night.
right. Have a good night.
See you.
Hey, Alex, mind if I call you?
Sure.
All right.
Good. Like my phone?
Yeah, I think so. That'd be better.
Okay, cool. Yeah, give me a call. All right, I will sign off here then. What's going on?
Hey. Oh, nothing. I'm sick. Like, sick. My head's just killing me.
Ouch.
Yeah. But yeah, I